What is differentiation? Unlike linear, differentiation already from when you used to have to draw tangent to curve at a specific point. It was primarily guesswork. You might have gotten something close but never an exact answer. Differentiation enables you to calculate it precisely by considering the gradient between 2 points with infinitesimally small distance between them. To do this, let's remind ourselves of the gradient formula. The change in y divided by the change in x. Now, we will rewrite this formula slightly differently. We call the first coordinate x and f of x. The second coordinate is x plus h and f of x plus h. Substituting those into the gradient formula give off f of h plus h minus f of x all divided by h. This setup is useful because h represents the small distance between the 2 points. By changing the h, we can control how close the point are. For differentiation, we want the most exact form of the gradient, so we let the h get close as to 0 as possible. However, setting h to 0 might cause division by 0, which we cannot do. To solve this, we use the concept of limit. F of s equal to x squared. Start with the formula, substitute f h plus h x plus h square or f of x square the formula from x square is square all divided by h. Expand the numerator to get x square plus 2sh plus h square minus h square cancel out by x square terms. Simplify by dividing each term by h. Finally, take the limit h to the 0. Give 2x to the derivative of square is 2x. We also have other techniques. For example, we have power rules, constant rule, function rule, product rule, exchange rule.
Hi guys, my name is Putri Nur Izaina Malkis and I'm going to show you guys how to do question 2. So for A, find dy over dx for y equal to 3x squared sine 2x. So in this function, there are two separate functions. So we need to use the product rule. So what is the formula for product rule? Formula for product rule is dy over dx is equal to uv prime plus vu prime. So we need to know which one is u and which one is v. So for u is 3x squared and for v is sine 2x. So step 2, we need to differentiate each part. U is equal to 3x squared. So to differentiate u, we need to multiply 2 with 3. So we will get 6x for u prime. And for v, we need to use the chain rule. Why? Because of 2x. To differentiate sine, we get cos. So cos 2x multiply 2. Where do I get 2? I get 2 from differentiate 2x. Differentiate 2x, we will get 2. So for v prime is 2 cos 2x. And the last part is, we need to apply the formula. So dy over dx is equal to 3x squared, which is our u, multiply with 2 cos 2x, v prime, plus sine 2x, v, multiply with 6x, u prime. So the final answer is 6x squared cos 2x plus 6x sine 2x. B. Use chain rule to differentiate y equal to sine x cubed minus 2x squared plus 1. This question asks us to use chain rule. So the formula for chain rule is dy over dx is equal to dy over du multiplied by du over dx. Meaning is we need to differentiate the outer function first, then multiply the derivative inside the inner function. Step 2. We need to know which one is the outer and inner function. So for our outer function is sine, and for inner function is x cubed minus 2x squared plus 1. So step 3, we need to differentiate the outer function. If y is equal to sine u, then dy over du is equal to cos u. As I said in the previous video just now, if we differentiate sine, then we will get cos. So for the inner function, we need to differentiate it too. So if u is equal to x cubed minus 2x squared plus 1, then du over dx is equal to 3x squared minus 4x. Meaning is x cubed 3 multiply 1, then you will get 3x squared. And for negative 2x squared, 2 multiply negative 2, then you will get negative 4x. Step 5. Apply the chain rule formula. So dy over dx is equal to cos x cubed negative 2x squared plus 1, which is our dy over du, multiplied by 3x squared minus 4x, which is our du over dx. So the final answer is 3x squared minus 4x cos x cubed minus 2x squared plus 1.
Assalamualaikum everybody. So today I will be teaching you on how to do implicit function. So when you use implicit function, we will use implicit function where there's y in the function. For example, here x squared tangent to y, there's y inside the function, inside there. So we'll use the implicit function. So I'll be dividing this into a 3 part. Okay. So firstly, I will differentiate e to x plus 1 using the chain rule. Now, when I differentiate to x plus 1, I will pull it down here and will multiply it by 2e. Alright, and then we get 2e to the power of 2x plus 1. Okay. Secondly, I will differentiate x squared tangent to y using the product rule and chain rule. Why is product rule? Because x squared is multiplied by tangent to y. After that, we let x squared equals to u and we let tangent to y equals to v. Then we will differentiate x squared using power rule and we get 2x, and we'll differentiate tangent to y with a chain rule and we'll get 2 dy dx second squared to y. Now, why do we get dy dx there? Because we differentiate it by y, so we get dy dx. Alright. Now, the answer that we've got, that we will put it inside of the product rule formula, v u prime plus u v prime, and then we'll get this here. Alright. So next, I will differentiate ln x y using the product rule and using the chain rule. Now, when I differentiate ln, it will become 1 over xy, and the xy inside here. To solve it, I need to use the product rule. So we let x equals to u and we let y equals to v. Now, I will differentiate using the power rule, and I'll get u prime equals to 1, and for y, I will get dy dx. Why dy dx? Because as I said earlier, y differentiate by, because we differentiate y, alright? Now, after that, we will apply inside our formula vu prime plus uv prime, and then we got y plus x dy dx, alright? And then y over xy will multiply inside of the bracket, and then we'll get 1 over x plus 1 over y dy dx, alright? And then I will write the answer back down. Then we'll separate the dy dx and the others, and then we'll factorize the dy dx, and then we will be divide the answer right here, right? Thank you. So today I will be teaching you on how to use linear approximation to estimate any value. So first, when you hear linear approximation, you need to think of this formula right here. Alright. Now you need to identify fx. We already identified the fx because it's already been given in the question right here. Now 15.98 looks like the closest to square root, so we will turn it into x. Alright. So, and the square root will turn it into a power using the power of indices, using the law of indices. Then we'll find f prime x. We'll differentiate what we have earlier using the power rule. This 1 over 2 will be heading this way, and it will be minus by 1. We'll repeat the same process with x to the power of 1 over 4. Then we will get 1 over 6x to the power of negative 1 over 2. In order to not make this a negative, we will drag this down into the denominator, and we'll get 1 over 6 square x. This will repeat the same process with this number. Alright. Now, we need to find the given value. How do we find the given value? The given value, we will write back the number that we turned into x earlier, and we will find the estimated number by using a square root. Now, we will use square root 16 because square root 16 is the closest square root to 15.98. Alright. Because square root 16 equals to 4. Then we can find the change value of x, and with that we use a given value minus by estimated value, and we'll get negative 0.02. Next, our fx earlier, we will replace the x with our estimated value 16, and we'll get negative 2 over 3. And our f prime x earlier, we will change the x with our estimated value 16, and we get 1 over 96. Now the last step, we need to apply the formula right here. Alright. And when you apply it, you will get the answer, negative 0.667. Thank you.
In conclusion, differentiation is the process of finding derivative, which tells us how a function changes at any point. It is based on the concept of limit and is one of the core ideas in calculus 1. Differentiation helps us to understand rate of change and to find slope of curve and tangent line. It also can solve real-world problems like optimization and motion. Okay, that's all about differentiation and the technique.
Thank you for the Karen for having me.
No problem.
Okay, let's go.
Let's go.